If electrochemistry numericals confuse you, today I will show you the exact thinking process before formula. Hello students, I hope everyone watched part 1, part 2 of electrochemistry theory part. Then we will continue numericals based on electrochemistry, which includes even PYQs. Let us start one by one. The first question, once you look at first question everyone, read from your side first question. The EMF of the cell nickel plus to 0.1 molar they gave, Ag plus 1 molar, Ag E0 for nickel plus 2 nickel is equal to minus 0.25 volt. Respect to 4 options given. So how we need to solve? See here, they are asking to find E0 for Ag plus and Ag. So direct formula we can use here. We know whatever they are giving here, it is anode, then other it is cathode. Whatever giving starting, that is anode and it is cathode. Now see the solution now. Here we know E cell is equal to, first you see answer here, E cell is equal to, E cell is referred as E0 oxidation part, that is nickel to nickel plus 2, that is oxidation part, plus reduction part E0 Ag plus 2 Ag. So E cell formula oxidation to reduction part. So nickel plus 2 given values here it is minus 0.25. But what they gave, see here, they gave nickel plus 2 to nickel. They gave here reduction potential, but here what we wrote, oxidation potential. Whenever we are writing reduction potential in terms of oxidation potential, sign changes. So 0.25 plus 0.80, then which is equal to 1.05 volt. 1.05 volt. Then here answer should be C. Next question. Zinc and zinc plus 2, C1 concentration, zinc plus 2, C2. Zinc for the cell delta G is negative if respective conditions given. First let us see here whatever given information. See first given information. So given information, zinc it is giving zinc plus 2, C1 concentration plus 2 electrons. Another equation, given equation, zinc plus 2, C2 concentration plus 2 electrons if it is gaining, it forms zinc. Net equation if you see, net equation, zinc plus 2, C2, and we know here solids will not mention, solids will not specify, only aqueous form will mention, and then here it is giving zinc C1 plus 2, zinc plus 2. So according to general formula, after getting net equation, you can write general formula E is equal to, it is concentration cell. For concentration cell, what we write? E0 cell value. For concentration cell, E0 cell value we write it as 0. So minus 0.0591 by 2 electrons involved log C1 by C2. So if you see concentration cell, if we make it as 0 here, so 0 minus 0.0591 by 2. So here log C1 by C2. Here what we can conclude? So E cell is positive. If E cell is positive, then we know delta G is equal to minus NF E cell. Then delta G is negative. If E cell is positive, delta G is negative. When E cell is positive? E cell is positive if we can specify, then you write like this, E cell if it is positive, if E cell is positive, then you can specify like this, delta G is negative, in turn minus NF E cell, that is delta G is negative. The when E cell is positive, when C1 less than C2. When C1 less than C2, then E cell is positive. So hence our answer should be here C. C1 less than C2, that is option C is correct. Next. See next question. The cell reaction for the given cell is spontaneous, non-spontaneous, different reactions given. So how we need to proceed? See. First I am writing here H2 giving 2H plus 2 electrons. 2H plus 2 electrons. Okay. Next. 2H plus giving, further how we can write? 2H plus 2 electrons. 2H plus 2 electrons giving H2. Means oxidation process, reduction process. See, one it is reduction, one it is oxidation. Both we showed. If we combine both the reactions, oxidation reduction parts, the net equation what you will get here, 2H giving 2H plus, concentration different. Concentration here it is how much? 10 power minus 3, 10 power minus 3 and 10 power minus, 10 power minus 1 and 10 power minus, see now. Values you see here, pH is equal to 1 they gave, pH is equal to 2 they gave. So here pH is equal to 10, pH if it is 2, concentration is 10 power minus 2, 10 power minus 1. So this part already we know. If pH is 2, then H plus ion concentration is 10 power minus 2 and goes on. Concentration cell directly I am writing 0 for E naught cell, 0.0591 by 2, 2 electrons involved. Log H plus ion concentration by right hand side by H plus of left hand side. So here it is whole square, because it is 2H plus. So now E cell is negative. So if E cell is negative, delta G is positive. Hence process is non-spontaneous. Process is non-spontaneous. Hence answer here option B, non-spontaneous. Next question. Consider this cell, information given about cell respective values. See the answer. So here H2, directly I am writing now reaction, whatever they mentioned here H3O and 10 information given. So directly I am writing now. So E cell is equal to, see same formula, Nernst equation, more weightage everywhere. E cell is equal to E naught cell minus 0.06 or 0.056 by 1 log, here H plus ion concentration. See H plus ion concentration also referred as, what you can refer? H plus ion concentration also referred as H3O plus, which is same as H3O plus, by concentration of Ag plus, concentration of Ag plus. So E cell is equal to, see E naught cell how we write? E naught cell, it is the combination of, E naught cell is the combination of silver plus 2 Ag, then hydrogen electrode given here, hydrogen electrode. Hydrogen electrode we know, here it is 0. So 0 plus E naught cell, 0 plus 0.8 minus 0.06 by 1 log, here H plus ion concentration by X. H plus ion concentration by X. So what we need to find here? Here we need to find X value. What is E cell value? E cell value given as 1 volt already. So 1 is equal to 0.8 minus 0.06 by 1 log H plus ion concentration given, means H plus ion concentration by X concentration. But here remember minus log pH or minus log H plus is equal to pH. So minus log H plus you can write like in terms of pH also. pH given as 5.03. It is given as 5.03. So minus log pH. So overall if we substitute all, then here X we should get it as 2.10 power minus 2 molar. 2.10 power minus 2 molar. Here answer should be option A. If you substitute all values, you calculate X value. Next, the standard potential of the reaction 298 by Kelvin using Kw, respective values given here. So how we need to do, see here. So answer for this, first H plus reaction. See here they gave one standard potential of the reaction. So how it comes, see here, H plus plus electron, which is equal to half H2, but here in E naught is equal to 0 and delta G naught is equal to 0. Why? It is reduction of hydrogen electrode. Standard reduction of hydrogen electrode, we take it as 0. And next reaction, second reaction, dissociation of water. Dissociation of water, what we do? Here H plus and OH minus, dissociation of water, which is at equilibrium. Dissociation of water at equilibrium. So for this what you can write? Delta G naught is equal to minus 8.314 298 ln, they mentioned here H2O, ln Kw value, ln Kw, or you can write 2.303 RT. So here we wrote RT ln Kw we wrote. Next, if you join both, here you will get equation H2O plus, if you add both, H2O plus half H2 plus OH minus. So here what you will get, OH minus is equal to, it is net cell reaction, right? So how we got net cell reaction? It is net reaction. So net reaction I am directly writing now. Whatever net reaction here we got, whatever net reaction here we got, so that is, you can make it equal to, 1 and 2, above join 1 and 2. So for that I am writing here minus NF N3 NF E3 is equal to, because anyway first is 0, no need to consider about first, 8.314 298 ln Kw. So if you substitute the values, N is 1, 96,500. So E naught 3 we need to find. All other values given, 8.314 into 298 into ln Kw how much? It is 10 power minus 14. Write clearly 10 power minus 14. So finally if you calculate here E naught 3, after calculation, here you will get minus 0.828 volt. 0.828 volt. Hence answer is A option. Next question. Hg plus 2 plus 2 electrons giving 2 Hg, E naught, and values also given. See the question. So here what we do, see answer here. First Hg plus 2 electrons giving 2 Hg, whose value also given 789 volt. Okay. Another reaction Hg, here it is giving Hg plus 2 electrons, whose value also given 0.854 volt. Both the reactions given already in the. So if you join equilibrium constant for another reaction, they mentioned here Hg plus 2, for this reaction they are asking about equilibrium constant. So how we got this reaction? We got this reaction just by adding 1 and 2. We got this just by adding 1 and 2. Okay. So whose value it is given as So how will you get? Total 1 and 2 equations we got. So values you see here now. Here there is value for first reaction, second value here. Whenever both are added, then you will get final here E naught value, because redox reaction it is. Redox reaction. So E3 is equal to E1, E2. Redox reactions you can add. Overall here you get minus 0.065 volt. Okay. Now after this we need to find equilibrium constant for given equation. So what you will get, delta G is equal to minus N F E3, minus N F E3. Okay. And then here we can make it equal to delta G is this value we know. At the same time we know if equilibrium constant delta G is minus 8.314, what do we write? R already we wrote, R is 8.314 only, 8.314 temperature, ln K equilibrium, ln K equilibrium. So if we from these two, what I can write? Minus 2 into F is minus 0.065 into, no, it is minus 0.065, that is E value, and 96,500 is equal to minus 8314 into 298 ln equilibrium constant. Equilibrium constant if you calculate overall, here you will get approximately 6.3 into 10 power minus 3. 10 power minus 3. So your answer should be option C. What we did, two reactions we added. Third equation we combined with equilibrium constant expression as well as normal NFE3. Next. See next, weak acid, two weak acid solutions. Read everyone question for 2 to 3 seconds. Read once. Then you see the solution here. Read everyone. Simple question here, two weak acids given, respect to pKa values given. Here we know pKa is equal to minus log Ka value. pKa is equal to minus log Ka. And now, according to the formula for weak acids, we know E cell is equal to what we mentioned, minus 0.0591 by 1 log. See here concentration same, so E naught cell becomes 0, that's why I directly removed E naught cell value, log Ka1 into C1 by log Ka2 into C2. Concentration is same here, C1 C2 they mentioned same, C1 is equal to C2, so no need to think about it. So directly you can write 0.0591 by 1 log. See if pH is 3, whatever concentration or whatever pK is 3, Ka value is 10 power minus 3. So here I can write 10 power minus 5 by 10 power minus 3 under root. So remember, if pKa is 5, Ka is 10 power minus 5 relation. So overall if we do calculation, E cell value will be 0.059 volt, E cell value. So hence the given answer matching, that is 0.059 volt. Next, electrolysis of a solution of MnSO4 and aqueous sulfuric acid is a method for the preparation of MnO2. Passing a current of 27 ampere for 24 hours gives 1 kg of MnO2. The current efficiency in this process is. They are asking about current efficiency in this process. See here we know W is equal to EIT by 96,500 into neta, current efficiency. Neta is current efficiency. So values you see here, value what they gave here, 1 kg of MnO2. They specified 1 kg of MnO2. So I am writing it as 1000 grams is equal to So equivalent mass. So what is here equivalent mass? So equivalent mass is equal to the molar mass by n factor. Molar mass by n factor. So what is n factor here? MnSO4, that is giving MnO2. Reaction you see here. Electrolysis of solution of MnSO4 in aqueous sulfuric acid is a method for preparation of MnO2. So here n factor MnO2 or MnSO4 plus 2 became plus 4. Here you can see plus 4 converted to plus 2 converted to plus 4, meaning n factor change is 2 here. So with this, if you see here overall, n factor, the molar mass of MnSO4 aqueous solution MnSO4 is 55 plus 50, MnO2, right? They are asking MnO2 it is 55 plus 32. So I can write here molar mass 987 by its n factor we have to mention. N factor is 2 because change you see. I it is 27 ampere, time it is 24 hours. So you can say 60 seconds, then followed by 60 minutes, convert into seconds here, and then 96,500. So neta value you need to calculate. Neta is current efficiency. Hence current efficiency is equal to 0.951. So 0.951 here it is equal to, you can say 95.1 percentage. So neta is equal to 0.951 or which is equal to 95.1 percentage current efficiency. So remember, neta is equal to 0.951 or 95.1 percentage overall in the given equation. So electrolysis of solution of MnSO4 in aqueous solution sulfuric acid is a method for the preparation of MnO2. Passing a current of 27 ampere for 24 hours gives 1 kg of MnO2. The current efficiency we calculated here. Overall we got 95.1 percentage. Next, see the next question. During preparation of H2SO8, O2 gas also released anode as byproduct when 9.72 liters of H2 releases cathode. Okay, see everyone for 2 to 3 seconds, okay, 5 seconds you can see the question everyone. So here what we can write, see about Marshall's acid H2SO8. At anode reaction we see first. At anode reaction, like directly I am taking 2H2SO4 giving H2S2O8 plus 2H plus 2 electrons. At cathode reaction 2H2O plus 2 electrons, 2H2O plus 2 electrons gives H2. 2H2O plus 2 electrons gives H2. Here what you can specify based on the reactions, you can go even this with method also. Number of equivalents of H2 is equal to number of equivalents of H2S2O8 plus number of equivalents of O2. Why? Here you see H2S2O8 produced in first reaction. In second reaction you see here H2 produced plus OH minus also there here plus 2OH minus. So here you see now at anode H2S2O8 produced, yes. At cathode H2 gas produced, yes. But they specified when 9.72 liters of H2 releases at cathode and 2.3 gas at anode, and they mention O2 gas also releases at anode. At anode we need to mention even O2 gas. So O2 gas also releases at anode as byproduct. So here O2 gas also releases at anode as byproduct if I see. So what happens here, observe it now. So H2S2O8 along with O2 gas, that's why I added here equivalent of O2 gas. They mention. So if we go with number of equivalents of H2, how we convert? 9.72, 9.72, or first to specify how many equivalence formula, number of moles into n factor, here also number of moles into n factor, right here number of moles into n factor plus number of moles into n factor, 3 cases. So number of moles first they gave here gas, so 9.722 by 22.4 liters at STP, n factor is 2 is equal to, here number of moles 2.35 into 4 by 22.4 plus what left here. So here now x into means here x moles, we don't know moles, x into n factor 2 only it is. So where x is equal to, here you will get 43.49. Approximate answer is option B. So number of equivalents we made it equal. Okay. Next, when the sample of copper with zinc impurity is to be purified by electrolysis, the appropriate electrodes are. So when the sample of copper with zinc impurity, so remember every time impure sample is made as anode and pure element we make it as cathode. Impure sample to be purified should be connected to anode and pure element we make it as cathode. So now here you can see pure copper as cathode and impure copper as anode. It is general theoretical question. Next, the reduction potential of hydrogen electrode when passed in a buffer solution, pH of the buffer they are asking here. See solution everyone. So direct I am writing now. Here E cell value is found to be reduction potential they gave here. So here E cell, or you can say reduction potential, E reduction potential hydrogen electrode, okay. ERP is equal to E naught standard reduction potential minus 0.0591 log 1 by H plus, log 1 by H plus. ERP that is given, how much? 0.413. Standard value we know it is 0, 0.0591, n value is 1, log, see here they gave pH of the buffer solution we need to find, H plus ion concentration, pH of the buffer solution. Here remember minus log H plus is equal to pH. So means we need to find minus log H plus value here. Minus log H plus value if you find, that is the answer. So here you will get, if you get calculate, here you will get pH is equal to 7. pH is equal to 7. This we need to find, both are same. Next question, given E naught Cr plus 3 Cr values given, once everyone refer question. First everyone refer question, then we will see solution here. So given value Cr plus 3 to Cr information given, then we have to proceed with the calculation of potential for this cell representation also given. See the question. First everyone try how to start first. You see how to start, then we will proceed. Take 2 to 3 minutes time and okay. See how we need to proceed here. C naught Cr plus 3 Cr, reaction 0.42 entire overall given. As usual, E cell is equal to E naught cell minus 0.0591 by 6. Why it is 6 here? Directly I wrote here 6 because how many electrons involved in the reaction? If you write overall reaction, 6 electrons involved in the reaction because you need to balance. While balancing, if you multiply with suitable number 3 and 2, you will get 6 electrons in above net equation. That's why I wrote n factor log Cr plus 3 by Fe plus 2. See net equation, if you write, you will get overall this one. Net equation. Already you know many questions above we solved. Net equation how to write. Easily can do it. So E cell value we need to calculate. E cell is equal to E naught cell is 0.3. How will you get 0.3? How you are getting 0.3? We need to add these values. E naught Cr plus 3 to Cr they gave, Fe plus 2 to Fe they gave. But net cell reaction, how you will get? Net cell reaction I am showing C here. For example, if I take Cr giving Cr plus 3, which is 3 electrons here. Another equation, it should be reduction, right? So I am changing Fe plus 2 to Fe. So here you will get 2 electrons. To make number of electrons equal, what we have to do? We have to multiply this with 2, another with 3 to make number of electrons equal. Okay. So during this process, to get net equation, cell representation they gave here, see, Cr plus 3, Fe plus 2, Fe reaction, but here what they gave? Fe plus 2 to Fe minus 0.42, but here chromium plus 3 to chromium value given, but here what we need? Chromium to chromium plus 3. So this we make it into plus 0.72, plus 0.72. Okay, plus 0.72 plus the given value, plus 0.72 plus this given value, which gives value here 0.3. So here plus minus 0.42 to get net equation, here you will get 0.3. 0.3 will get same value I substituted here, 0.0591 by 6. So log here 0.1 whole square, 0.101 whole square. So whose value, which is equal to 0.26. Option 4. Next question. The reduction potential of hydrogen half cell will be negative if when. See this solution. Answer for this. Reduction potential, reduction reaction I am writing here 2 electrons H2. So reduction potential like is equal to E naught SRP reduction potential 0.06 or 0.0521, anyone you can take, log H plus ion concentration square by partial pressure of H2. Partial pressure of H2. So if partial pressure of H2 is equal to 2 atm, H plus is equal to 1 molar. Under these conditions, reduction potential, this one, it will be negative if pH2 is 2 atm, H plus is 1 molar. 1 molar, because anyway E naught R, see E naught, what is standard E naught R? That is 0 only. Standard E naught R value here we know it is 0, we assume it as 0. For SHE, standard hydrogen electrode, standard reduction potential, standard oxidation potential assumed as 0 because of negligible potential. So when these two, pH2 is 2 atm, H plus is 1 molar, then you will get here negative value for E naught Rp. Okay. Next we see question. Here they are giving values. Based on the data given above, strongest oxidizing agent will be. So how to find strongest oxidizing agent? The values whatever they gave here, the values given here, all are reduction potentials. Reduction potentials. So how we proceed with this reduction potential? First of all, see here, as reduction potential increases, strength of oxidizing agent increases. Among all, which is having highest reduction potential? Highest reduction potential is for MnO4. So you can write, since MnO4 minus having highest reduction potential. How we got no reduction potential? See, Cr plus 3 became Cr, means charge decreasing, reduction potential. MnO4 became Mn plus 2. Mn is plus 7 charge here. It became plus 2. So charge decreasing. So all are reduction potentials. Hence, since MnO4 minus highest reduction potential, it is strong oxidizing agent. So answer is MnO4, option 4. See the next question. 2 farad of electricity is passed through a solution of CuSO4. The mass of copper deposited at the cathode is 2 farad of electricity passed. See question everyone. Simple here it is. If 2 Faraday solution here you see CuSO4 which gives Cu plus 2 SO4 minus 2. Cathode we know here it moved towards cathode. So at cathode Cu plus 2 gain 2 electrons and it forms Cu solid. Now in question you see how many, see 2 moles of electrons means 2 Faraday electricity is passed. 2 Faraday electricity is passed through a solution of CuSO4. Mass of copper deposited. It's the same equation they are asking. 2 Faraday current passed. So how many moles of Cu formed? Here 1 mole of Cu formed. 1 mole of Cu mass is 63.4. See, molecular mass only it is. Option 2. Next. Galvanization is applying a coating of. So here in this overall PbCr copper zinc, it is general question. See, galvanization is the process where in galvanization what we do here, there is coating of iron by using zinc. So here galvanization process, so coating of iron by using zinc. So whenever there is galvanization process, we coat iron by using zinc process. Next question, see here. The Gibbs energy for the decomposition of Al2O3 at 500 degrees Celsius is as follows. So Gibbs energy information given for the decomposition of Al2O3 at 500 degrees Celsius is as follows. So the potential difference needed for electrolytic reaction Al2O3 at 500 degrees Celsius is at least. So see the question here, what they are asking. See, Gibbs energy for the decomposition of Al2O3 information given. So in this case, how we need to prolong? See, first observe it. Observe the question everyone. Observe the question, then we will see. See, Gibbs energy for the decomposition of Al2O3 at 500 degrees Celsius. So first I am writing reaction Al2O3. Here it is giving 4 by 3 Al plus O2. So Gibbs energy for the reaction is equal to what we write, 966 delta G, the value they gave 965 kilojoule per mole, information given. Then, so 965 kilojoule per mole meaning 965 into 10 power 3 joule per mole. Yes. After that, we know Gibbs energy formula minus NF E cell. So here you can make it equal 966 into 10 power 3 is equal to N value here. N value in above equation. How many electrons we cancel in above equation? Means if you balance reaction, here N value you will get it as 4, F value 96,500, then E cell value. How will you get 4 here? Equation if you see, after joining both, or you can say change in oxidation number, you will get 4 only here. Change in oxidation number also you can calculate. N value 4 you will get. Then followed by E cell here is equal to 2.5 volt. Direct relation 2.5 volt, that is third option. You focus here, key point is N value is 4. You can check the difference. See Al2O3, what is the value of? We know Al is plus 3. Here it is 0. Plus 3 becomes 0, and in coefficients you need to consider. 2 by 3. 2 by 3 Al2O3 giving Al, that is you can say here plus 3 here converted into 0. But how much? 2 by 3 part. If 1 mole, that is fine, 1 mole that is fine, but 2 by 3 part, how much we need to see here. Overall you will get here 4, and you know how to calculate N factor and see here. Next, for the reaction 2 Fe plus 3, see next question, that is for the reaction to Fe plus 2. First everyone read the question. First you try to think from your side how we need to start the question, the approach. See, they gave Fe plus 3 aqueous giving 2I minus 2 Fe plus 2 and I2, and goes on, they gave certain values. So how to do? See, started with for the reaction here question. Yes, see here like Latimer based question it is, Latimer representation type question it is. So they are asking about the magnitude of the standard molar free energy change delta G is equal to dash. They are asking about it. Okay. So here we know Fe plus 3 gives Fe plus 2, which is giving Fe, which is giving Fe. For the reaction magnitude of the standard molar free entropy change, energy change delta G naught is equal to dash, they mentioned. So here if I take it as E1, E01, here if I take it as E02, from here to here I can take it as E03, E03. So here we know according to reaction sequence, see here 1 electron lost, here 2 electrons, see 1 electron gained in first step, 2 electrons gained in second step. So what I am writing now, here E01, or write like this, E01 plus 2 into E02 is equal to 3 into E03. Why here? See what is the value of N? Here N is equal to 1, 1 electron. N2 is equal to 2 electrons. N3 is equal to 3 electrons involved in the reaction. So all sum of these 3 we mentioned here. So E1 plus 2E0 is equal to, so here what you can do, E01 is equal to, you can do here 3E0 minus 2 into E02. So which is equal to E03 is minus 0.003, sorry, 0.036 minus 2 into minus 0.44, 0.44. See values given here. I will show you in question, actually here it's not showing. These values also given in the question. Once again see, it is question part. Here those values not showed. The values what they gave here, Fe plus 3, Fe plus 3 2 Fe plus, or you can Fe plus 3 to Fe, this value given, that's why I wrote directly here, so which is equal to 0.036 minus 0.036 value given. Another value also given, which is Fe to Fe, which is given as minus 0.44. These values given in the question, that's why I wrote directly here. So which is equal to 0.772 volt. Once if you know here values, the delta G of the reaction, entire reaction, is equal to NFE. Which reaction they are asking? Fe plus 3 to Fe plus 2. So this one only they are asking in question. NFE1. Substitute the value, which is minus 2 into 96.5 into 0.233. No, iodine also there, just a minute. Here we got E naught value, but E naught cell we need, right? Here E naught cell. So it is E naught 1 value. Means one particular part. E naught 1 for which one we wrote? That is for iron. But E cell value we write here. E cell is equal to, directly wrote 0.233. E cell is equal to E naught Fe to Fe plus 2 plus 3 to Fe plus 2 plus E naught I minus 2 I2. I minus 2 I2. So even this value also given. Here I minus 2 I2 value also given. 0.233 we got here value, right? See now 0.233 value we got. Here even this value also given, you take it E naught I minus 2 I2, which is equal to 0.539. 0.539, which is minus 0.539, minus 0.539 value given. So if you substitute those values here, you will get 0.233. 0.233 value finally here we will get. See question with E naught value, which is for Fe plus 3 to Fe plus 2. Other value, which one? This one, I minus I2. If you add both, you will get 0.23, so which is E naught cell. If you substitute here 96,500, 96 point, what they mentioned here? Yes, nothing specified in the question. Okay. Kilojoule. So directly we are giving answer in kilojoule, that is minus 45 kilojoule is answer. See question once again. Important question. They gave 3 steps overall. They are asking about Fe plus 3 to Fe. By using Latimer representation type, first we calculated E1 value, first reaction value. If we combine with I minus I2, we got E cell. Substitute in the formula delta G. Next question. Molar conductivity of infinite dilution, values given. Here we know from Kohlrausch law, what we can write? Of BaSO4, barium sulfate, is equal to Ba plus 2 plus at infinite dilution SO4 minus 2. These values given. So all other values given here because they mention sulfuric acid, barium chloride, and then certain other values. So how you will get here? How you will get the equation? See, to get this equation, we need to find this one. They are asking about barium sulfate. So how to get this equation? They gave respective values. What are those? Barium chloride they gave. Barium chloride is lambda m infinity of Ba plus 2 plus 2 into Cl minus, equation 1. Sulfuric acid, lambda m infinity of sulfuric acid H2SO4, which is 2 into H plus lambda m infinity for SO4 minus 2, equation 2. And hydrochloric acid also given, lambda m infinity of HCl is equal to H plus Cl minus, equation 3 also given. So we need to get equation 4 by using equation 1, 2, 3. So how you can write? Equation 4 is equal to 1 plus 2 plus minus 2 into, means here what we are doing, reverse. Here what you can do, reverse and add it, reverse equation 2, 2. See, whenever we are reversing, then what we do, sign changes, 2 into reaction 3, this one we take. See, if we reverse and add, then only we can cancel unwanted terms. So what we are getting here, one value is 280, second value 860, 426. Overall answer is 288 Simon centimeter square per mole. Simon centimeter square per mole. Okay. So that is about previous year questions we studied, even practiced questions, some important questions based on electrochemistry. So around you can see 19 questions we studied based on electrochemistry. Everyone once again properly go through from starting to these 19 questions of electrochemistry, different question models we studied. Okay. And next we are going to start coordination compounds. First you complete electrochemistry, be confident in all these questions and theory part, then follow upcoming lectures that is based on coordination compounds. Thank you very much.